Unit 6, day 3 and 4, homework. Example 1. Don't do example 1. Don't worry about example 1. I do not want you to expend more mental energy than is required to do this assignment. What we really need to focus on is 2, 3, 4, and the rest of them. We've got to get these down. It requires a lot of focus, a lot of discipline, a lot of paying attention. And I don't want to waste that on this. If I feel that this is going to be necessary, I will make sure we will review it on review day. So for right now, don't worry about it. Let's move on to example 2. The Arabs kicked a soccer ball with an initial velocity of 45 feet per second at an angle of 32 degrees to the horizontal. After 0.6 seconds, how far has the ball traveled horizontally and vertically? Let's set up our component vector. Initial velocity is 45 feet per second. T cosine, and then our angle is 32 degrees, comma, 45 T sine 32 minus 16 T squared. Remember, this X portion of our component vector is the X equals portion of our parametric equation. It also covers horizontal distance. This Y portion covers vertical distance. So if they want us to solve how far is it horizontally after 0.6 seconds, then we're just going to substitute here for T. Let's plug that into our calculator. Looks like 22.897 feet horizontally. So how far does it travel horizontally? That much. Now let's go find vertical. This is vertical distance. So everywhere we see a T, we're going to substitute 0.6. All right, let's plug that into our calculators. $8.548. So how far is it vertically at 0.6 seconds? That would be 8.548 feet above the ground. Example 3, a dart is thrown upward with an initial velocity of 58 feet per second at an angle of 41 degrees. Find when the dart will hit the ground. Let's set up our parametric equation first. Start with your velocity. And then angle. Now that we have our parametric equation set up, we can begin to solve this problem. Find the maximum height of the dart. That's one of the things we're solving for, and find when the dart will hit the ground. Both of these types of questions here, get it in your head. Find when it will hit the ground, find the maximum height. That is going to be this portion of our component vector there. So what we're going to do is we are going to go to our calculator, go to the Y equals portion, and let's plug in this formula here. Clear out any previous data. 58x sine 41, close those parentheses, minus 16 x squared. And let's graph it. Let's make sure it doesn't look funny. That looks pretty similar to what our other parametric equations have looked like. So we're probably on the right track. Okay, let's first solve for when will the dart hit the ground. So here's what we're looking for. This equation, here it goes. This is the function. You see what it's doing there? That's what it's doing. It crosses the x-axis twice. Here at 0, but we don't include that one because that's where we're starting. It goes up and then it hits the ground here. Boop. Well, what x-intercept is that? Right there is the first x-intercept. There's the second x-intercept. There's the third. This graph, the ball falls in between the x-intercepts of 2 and 3. Remember that. So let's go figure out where exactly does it fall in between 2 and 3. And the way that we're going to do that is we're going to hit second, trace, highlight 0, push enter. Now remember, it falls in between the x-intercepts of 2 and 3. So we want to go in that order. On your calculator, push the 2 button and then enter, and then the 3 button and enter twice. That's the x-intercept. That's where it hits the ground. That's how long it's going to take to hit the ground. 2.378 seconds. Okay. Now find the maximum height of the ball. Back to our calculator here. Let's do second, trace, highlight maximum, and push enter. Now what we want to try and identify here is where is our axis of symmetry? Remember from Algebra 2, axis of symmetry is where would we split this graph right down the middle and it be symmetrical on both sides? Well, it's kind of hard to tell because the graph doesn't fit entirely in the window here. But I think if we can probably use a little bit of logic, it probably hits its maximum here. So from there, if I were to split this graph down the middle, it looks like we would go through the x-intercept at 1. You see right where the tip of my pen is pointed? That is the first x-intercept. Well, what intercept comes right before 1? 0. What intercept comes right after 1? 2. So now that we have done, and I want to do it one more time, second, trace, maximum, we want to do 0, enter, 2, enter, enter. And now what we have is we know what the vertex is. I believe all it wants to know is the maximum height of the dart, and that would be the y portion of our vertex. So the maximum height is 22.624. And that example is now completed. Example 4, a golfer hits a ball with an initial velocity of 133 feet per second at an angle of 36 degrees from the horizontal. When and where will the ball hit the ground? Let's set up our component vector. Velocity, t, cosine angle. Velocity, t, sine angle minus 16t squared. What we're solving for is when and where will the ball hit the ground? Well, let's start with answering when. We're going to go to our y equals portion of our calculator here. and we're going to plug in the y equals portion of our parametric equation. Clear out any previous data. 133x sine 36, close those parentheses, minus 16x squared. Let's graph it. Let's make sure we didn't do anything weird. Hey, that looks about right. Okay, let's figure out, where does this hit the ground? This is x-intercept 1, this is x-intercept 2, this is x-intercept 3, this is x-intercept 4, this is x-intercept 5. It looks like this ball hits the ground in between x-intercepts 4 and 5. Keep that in mind. Let's go find out what that point is. Second, trace, highlight 0, enter. Remember, it falls in between x-intercepts 4 and x-intercepts 5. So we're going to do 4, enter, 5, enter, enter. Looks like that ball hits the ground in 4.886 seconds. Now, to solve for where will the ball hit the ground, what we are going to do is, now that we know it hits the ground at 4.886 seconds, we're going to take this and substitute it for t for the x equals portion of our parametric equation. Where? And now let's plug that into our calculator. We get 525.729. Well, we're normally rounding to the thousandth, right? So we look behind the thousandths place to see if that number will round up this number, and it will. So since this is a 9, it will round up to now 10. It's going to round up to 3. So where will it hit the ball? At 525.730 feet away.